Alright, so we already did the intro. We're going to kind of do a little bit more with the integral here. All this information is the same as the last video. So let's go ahead and go on to the next page. Okay, so we're going to apply some of these properties that we've learned from the last page, and we're also going to kind of use some of our algebra skills to simplify some expressions before we take the integral. So let's take a look at this first one. Remember that we can rewrite this as simply the integral of x dx plus the integral of 3 dx. And now this becomes a lot simpler to evaluate, right? So the integral of just x, we found out that's going to be, you add 1 to the exponent divided by 2, plus the integral of 3 was 3x. Right? We just simply kind of multiply by an x there, plus, again, some constant. And so we have evaluated this indefinite integral. Let's go to the next one, because it starts to get a little bit more interesting. See, now we have something funky going on, and as I look at this, this looks confusing to me. So what I'm going to do is I'm going to convert this back to its fractional exponent form. So this is really like saying x to the 2/3 dx. Well, now I could just simply use the reverse power rule, right? So x to the 2/3 would be like saying you do x to the 2/3 plus 1 in the exponent, and then we're going to divide by this new exponent, and of course plus some constant c. Well, we're going to want common denominators here, right? So instead of 1, maybe a better idea would be think of that as 3/3 and 3/3. And so this would be x to the 5/3 over 5/3 plus c. Well, remember, when you're dividing by a fraction, it's the same thing as multiplying by the reciprocal. So this is actually equal to 3x to the 5/3 over 5 plus c. And there you go. Okay, we're on to the next page here, and we see that we have two expressions being multiplied together. And so your instinct may be, oh, is this some type of product rule or something? And the reality is, no, it doesn't have to be at all. It's actually quite simple, right? Because this is really like saying the integral of y squared times y to the 1/2 dy. Well, we have a rule about when we multiply two things with the same base, we could just add their exponents. So really this is like asking for the integral of y to the 2.5 dy. Or if you wanted to think of it as fractions, it's y to the 5/2 dy. Either way, pretty simple to evaluate this. We just simply take y to 2.5 and add 1, making it 3.5, dividing by the new exponent, and of course adding c. The only thing that I would do here is, this is kind of weird to have a decimal inside of a fraction, and so we could think of this as y to the 3.5 over 7/2 plus c, and then we could flip that denominator and multiply and make that 2y to the 3.5 over 7 plus c. And that's probably the cleanest way to write it. You could have also replaced this with the 7/2 if you want. But other than that, it's pretty good. All right, let's do another one. All right, so again, we have a multiplication here, but that's okay. Let's just go ahead and multiply these. Let's distribute that t squared. Well, we would end up with the integral of t squared plus 3t cubed dt. And we could separate this as two separate integrals, or we could just go ahead and just know that we are allowed to take the integrals of these two expressions separately. And so we would get t cubed over 3 plus 3t to the 4th over 4 plus c. And there you go. Pretty straightforward. All right. Again, now we have one that's a little complicated because we have a function inside a function, so you may be thinking, oh, is this some type of chain rule? And there is a reverse chain rule that we're going to use, that we're going to learn, I mean. But for now, this is actually not that bad because we can just simply go ahead and box method this thing out. Let's see what we would get. Or we could just square it. t2 squared minus 1 times 2t squared minus 1. Well, this would be 4t to the 4th, negative 2t squared, negative 2t squared, and then positive 1. So really this is like saying what's the antiderivative, or the integral, of 4t to the 4th minus 4t squared, because there's two negative 2's in there, plus 1. Okay, not so bad. Let's go ahead and do the antiderivative of this. Well, we got 4t now to the 5th divided by 5 minus 4t to the 3rd now divided by 3 plus 1 would just become a t, and then of course plus some constant c. Okay, so it's really not that bad. Okay. Work our way through these things pretty easily. Let's go to the last page where there's a lot of fun problems. All right, I like this one. See, as you look at this one, you're thinking, okay, what the heck is going on? But again, remember, there are ways that you can manipulate this so that it's not, a function over a function. The first thing that I see, actually, is that we could separate this as 3 separate fractions. They already have a common denominator, so you could write it as 3 separate fractions with that common denominator. If you think about it, you got x squared over x to the 4th plus 2x over x to the 4th minus 3 over x to the 4th, and that's dx. All right, well, now these all simplify in a different way. So let's go ahead and do that. This is like asking for the integral of, see, these the x squared here would cancel out, and this would just become a 2. And so you could actually write this as x to the negative 2. And we're fine with that. We know how to take the antiderivative of that. Plus, this one would cancel out at least one of the x's. And so this would become plus 2x to the negative 3. And the last one, there's no x's to cancel out, so this is just simply becomes negative 3x to the negative 4 dx. I use parentheses here because really, remember, it's the function height times the width that gives us the area of the rectangles underneath the curve. That's kind of where this notation comes from. So there should be parentheses here because it should notate that you're going to multiply this whole thing by dx. All right. Well, we can take the antiderivative of this relatively easily. Add 1 to negative 2. You end up with negative 1 divided by negative 1 plus 2x instead of negative 3. It now becomes negative 2 divided by negative 2 minus 3x instead of negative 4, now becomes negative 3 divided by negative 3, and of course plus some c. And now we just need to clean this thing up. So this is really like saying negative 1 over x, and here the 2's cancel out, so this is really just like saying minus, because there's still a negative, 1 over x squared. And here the negative 3's actually cancel out, so this is like saying plus 1 over x cubed plus some constant. There you go. All right. I think you can do the last two on your own. I want you to give it a try. Don't be confused just because there's a theta here. It doesn't really matter. It doesn't really matter what the variable is. The rules are the same. Give these two a try and then check back and see if you get them correctly. All right, add 1 to the x1 of 3, you get 4. Divide by that 4, you get 7/4 theta to the 4th power plus c. Here, convert it to x to the negative 2, and you can easily see you're just going to add 1 to that, giving you negative 1, and dividing by negative 1 plus c. This, of course, simplifies to negative 1 over x plus c. There we go, folks. Pretty easy stuff. The antiderivative or the indefinite integral is actually not all that scary. See you guys in the next video.